Okay, guys. So now that we understand that current is inversely related to resistance and is also related to the number of paths, we can look at this more complicated circuit that we have here. Now, our equations are going to say that the current on the path A and equals the current of path B plus C. We know this because we have one path splitting off into two, so the addition of the two must equal the first path that they came from. Also, if we look, since there's half as much resistance on B, it has to be double the current because the resistance is inversely related to the current. You see, on B there's 1 ohm. There's a resistor with 1 ohm and another resistor with 2 ohms, which equals 3 ohms. And on C, there's a resistor of 6 ohms. Since 3 ohms is half as much, there's going to be more current going through B because it's hard. It's easier for the electricity to go through it, the electrons to go through B. So if we do our basic math, off of calculating resistance. Since this isn't on resistance, I just calculated it for you guys. I did 6 volts over 5 ohms, and that's 1.2 amps. That's for that's for what's coming out of B and C as this whole junction right here. So since the resistance is half as much on path B, that means that the current's going to be double, so it has to be zero point 0.8 and C has to have 0.4 there. So yeah, next path. Okay. So current is at odds with resistance. We know this. So the more the more room that you have, the easier that it is for electrons to move down the path. The the faster they're gonna move down the path. The more that they're gonna move. The more resistance we have, it's just gonna make it harder for the electrons to move through the circuit. And that's that. That's how current works. Thank you.